another example. In this example, we are trying to find the derivative of a tangent function, but it is not just a tangent of x, it's tangent of a radical function. So guys, the first thing first, what we have to really observe here is that the tangent function is again raised to the power invisible 1. So if it is raised to the power 1, we can directly start by using the general formula for the derivative of the tangent function, which we know is that the derivative of the tangent of x is secant square x. So we start with that, and then we may have to multiply by the derivative of the inner. Okay, so this y prime is going to be secant square radical x square plus 1, right? And then we got to multiply by the derivative of the inner, and that is, in this case, is going to be d over dx of radical x square plus 1. Okay, that is my first step, because we already know that the derivative of the tangent function is the secant square of that function. And then we have to use the chain rule, because it is not just simply x, it is a composite function. It's a combination of different functions, right? So let us now we see what else we can do here to simplify this. Guys, this is already done here. We cannot really do much with this piece, but here we can actually evaluate the derivative of this function, and then we just have to just write it next to this secant square function. So to find the derivative of this function, I'm just rewriting this secant square of radical x square plus 1. Guys, the first thing I'm going to do is, well, we can do it right here. You know, in order to find the derivative of an algebraic function of this form, guys, we want to try to rewrite this, or we want to have it in the form x to the power n. So we can just, instead of writing it as a radical, what we can do is we can write this as raised to the power 1/2. We know that the radical is the same as raising to the power 1/2. Now this looks like of the form x to the power n, where n is 1/2. And now we know we have to use the power rule, or you can also think of that as the chain rule here, because there's a combination, there's a composite function again going on here. So it's times, you bring the 1/2 up front, and then I have x squared plus 1 raised to the power 1/2 minus 1. 1/2 minus 1 is just negative 1/2, so I can just write negative 1/2 here. But then I have to multiply by the derivative of the inner. In this case, I have to multiply by the derivative of whatever is inside the parentheses, which is x squared plus 1. The derivative of x squared is just 2x, and the derivative of 1 is 0, so there's no need for us to write that. Guys, I think we're almost done, but we can simplify maybe a few things. Obviously, this 2 and this 2 will cross out. And then since we don't usually like to write the negative exponents, let us bring it downstairs, and it will change to a positive exponent. So we can write it like this. I'm going to write the algebraic function up front, and then multiply it with, and then the trig function. So it's going to be x divided by, when I bring it downstairs, it's just going to become square root of x squared plus 1. Right, because when I bring it downstairs, it's going to become x squared plus 1 raised to the power 1/2, which is same as the radical of x squared plus 1. And then, guys, multiplied by secant square of radical of x squared plus 1. That is it. Again, keep in mind, this is a trig function. It is not multiplied, it's connected together. It's a function by itself. So it's not like we can just cross these out, because it's not multiplied to secant. It's a function by itself. So this is going to be my final answer. Guys, please do not try to cross these out. You cannot, because it's a function by itself, right? It's a trig function, and this here is an algebraic function. So you cannot just cancel or cross those out, okay? Example 2, guys, I will see you in the next video with another example. I'm going to show you probably 5 examples in this section, so that you get to see different variety of examples. Again, my goal is that you see different types of examples, and you become confident, and you are comfortable working with these problems on your own. Okay, till then, take care. See you next time.